Hi, welcome. Today we are going to look at hypothesis tests for mean when the sample size is large or when the population standard deviation is known. And when we say the sample size is large, it means that the sample size, which is n, is greater than or equal to 30. For hypothesis testing, we are going to follow these 5 steps. Okay. The first step is to state the null and alternate hypothesis. And the second step is to select a level of significance. And then the third step is to identify the test statistic. And then the fourth step is to formulate a decision rule. Okay. And then the fifth step is to take a sample and arrive at a decision. So these are the 5 steps we are going to follow. So let's take our first question on this and then follow the steps. Question 1 says, homeowners claim that the mean speed of automobiles traveling on their streets is greater than the speed limit of 35 miles per hour. A random sample of 100 automobiles has a mean of 36 miles per hour and a standard deviation of 4 miles per hour. Is there enough evidence to support the claim at alpha equals 0.05? So we are going to follow the 5 steps to do this. Now, to solve this, the first thing you are going to do is to write step 1. State the null and the alternate hypothesis. You write that, okay. Now, after writing that, then you state them. So how do we state the null and the alternate hypothesis? First, we write H naught, isn't it? Then we bring our column. Then under it, we write HA or H sub 1. Okay, then we bring a column. Then we go back to the question. It says, homeowners claim that, so this is their claim, that the mean, so it's a mean, not proportion, the mean speed of automobile traveling on their streets is greater than, so greater than the speed limit of 35 miles per hour. Remember, in the introductory part of hypothesis test, I told you that the statement greater than is a statement of inequality. And statements of inequality, we assign them to what? To the H sub A or H sub 1. So if that is the case, we are going to write mu, which is mean, is greater than 35 miles per hour. Okay. You can write the mile per hour in front of the 35. Okay. Then, what is the opposite of greater than? It is less than or equal to. So we are going to write mu less than or equal to 35 for the H naught. Okay. Now you should also be able to identify which of them is a claim. So which of them was a claim? It is H sub A, isn't it? So you can write it at the front of it in bracket. Okay. H sub A is a claim. Also, you should be able to know the type of test that it is, whether it is one-tailed test or two-tailed test. To know, you just check the alternate part. When you check the alternate part, you have a greater than sign here, isn't it? Whenever you have a greater than sign or a less than sign, it is one-tailed. But when you have a not equal to sign, it is two-tailed. Okay. Then we go to step 2. Then you write step 2, select a level of significance. Okay. Now it means that the statistician will select his level of significance depending on what he is studying. But since the question has given us what to use, so we are going to use what the question gives us. Okay. So select a level of significance. We write under it alpha equals 0.05. Then we go to step 3. In step 3, we write that identify the test statistic. So how do we identify the test statistic? Now, to identify the test statistic, it means that you should determine whether we are going to use T or Z. When you look at the sample size, they say a random sample of 100 automobiles. So the sample size is large. Okay, it is more than 30. So since the sample size is more than 29, let me see, because the condition is that it should be greater than or equal to 30. So let's say since it is more than 29, okay, means that we are going to use a Z distribution. When you read the question further, let's check the standard deviation. They say a random sample of 100 automobile has a mean speed of 36 and a standard deviation of 4. Now, it means that when we take a sample of 100, they say it has a mean. What has a mean? Sample has a mean. So that makes this mean sample mean. You get it? And then when you go further, you see this word and. And is a conjunction. Okay. It means that if this mean is referring to this sample, then this standard deviation is also referring to the sample. So it means that this standard deviation is a sample standard deviation, not a population standard deviation. Kofi's father has 2 children, Kofi and Ama. Who is Ama's father? It means that Ama's father is Kofi's father. Do you get it? So when I say a random sample of 100, which is like the subject, has, which is a verb, a mean speed of 36 miles. So this mean is a sample mean, it's referring to the sample. So because of this conjunction and a standard deviation of 4, so the standard deviation is also a sample standard deviation. But here, even though we do not know the population standard deviation, since the sample size is more than 29, it's already a good reason why we need to use the z. Okay, so you write that the test statistic is the z distribution. You can also write the reason. Okay, you can write that this is because the sample size is greater than or equal to 30. Also, you can write the formula for z, that z is equal to x bar minus mu divided by standard deviation over root n. Okay, you can also choose not to write it, but what matters is that you should be able to state the test statistic you'll be using. Then you go to step 4. For step 4, you write that formulate a decision rule. So to formulate a decision rule, this is what we're going to do. We're going to sketch a normal curve. So we draw the line and then sketch a curve. Now when you sketch the curve, then go back to the set of hypotheses to check if it's a right tail test or a left tail test or a two tail test. When you look at this, this is a right-tailed test, isn't it? Since it is a right-tailed test, then you shade the right tail. Now, after shading the right tail, then you take the level of significance, which is 0.05, and give it to the right tail. So the shaded portion, which is the right tail, is 0.05. Okay. So the shaded region is known as what? Region of rejection. Okay, or area of rejection. And then the unshaded region is known as region of acceptance or area of acceptance. Okay. Now, after giving it to the shaded portion, we are going to find a critical value of z. Okay. We need to find a critical value of z. As in the z score, that should be here. That should be at this line. Okay. Now, to find a critical value of z, it depends on the table you are using. If you are using the full z table, you say 1 minus alpha. And please, we are using 1 minus alpha because it is a one-tailed test. If it were a two-tailed test, we divide the alpha by 2 before subtracting. But because this is a one-tailed test, we say 1 minus alpha. If you are using a half table, you say 0.5 minus alpha. Okay. So 1 minus 0.05, which is alpha, will give us 0.9500, isn't it? And also 0.5 minus 0.05 will give us 0.4500, isn't it? So let's go and check the table. So 1 minus 0.05, which is 0.9500, we look for it at the middle here. So we are looking out for 0.9500. So 9500. So we have 0.9505 here, and then we have 0.9495 here. So 9500 is between them. Okay. So since 9500 is between them, we take their various z-scores and then find the average. So what is the z-score of 9495? It is 1.64. And then the z-score of this should be 1.65. So take 1.64 plus 1.65 divided by 2. You get 1.645. Okay. Let's use the half table also and see. 0.5 minus 0.05 give us 0.4500. Leave it in 4 decimal places. So we are looking for 0.4500. So we have 0.4505 here and 0.4495 here, which is between them. So when you check it, you have 1.64 and 1.65. So when you find the average, you get same answer as this. So 1.645. So the critical value of z that will be here is 1.645. But I've decided to approximate it to 2 decimal places. That is 1.65. Okay. Then next, after getting the critical value of z, then you formulate the decision rule. So to formulate the decision rule, you say if z is greater than the critical value of z, which is 1.65, reject the null hypothesis. But if z is less than the critical value, which is 1.65, do not reject the null hypothesis. Or you can say fail to reject the null hypothesis. Remember that in our previous tutorial, that's the introductory part of hypothesis test, I gave you the decision rule that if computed value of z is greater than the critical value of z, reject the null hypothesis. But if computed value of z is less than the critical value of z, do not reject the null hypothesis. That is when you ignore the negative and use the positive for interpretation. So we've been able to formulate the decision rule. So this is it. Okay. So step 5, we take a sample and arrive at a decision. So in step 5, we can now calculate the test statistic. So that is z is equal to x bar minus mu divided by standard deviation over root n. Okay. Remember I told you you can write the formula here. But because I know I'm coming to write the formula in step 5, I decided not to write it here. Okay. Now let's look at the question and then get our x bar, our mu, and then the standard deviation, the n. Now the mu, the population mean is always what you have in the claim. So the 35 is the population mean. Okay. And then the sample mean is this 36. It says a random sample of 100 automobile has a mean of, even though the question didn't say sample mean, but because it says a random sample of 100 has a mean, meaning this mean is referring to the sample. Okay. For instance, when I say Mr. Benson has a dog, it means that the dog is Mr. Benson's. Do you get it? So this mean is a sample mean. So our sample mean is 36. So we substitute 36 there. So we are going to have what? 36 minus 35 divided by. Now, when you look at this, the standard deviation is 4. Remember that this is also a sample standard deviation. Okay. So since it is a sample standard deviation, we just replace a sample standard deviation with a population standard deviation. We have 4 divided by root 100. 36 minus 35, you get 1. Okay. And then 4 divided by root 100. Root 100 is 10. And 4 divided by 10 will give you 2 over 5. Okay. And when you put that on your calculator, you get 5 over 2. And 5 over 2 in decimal will give you 2.5. So you can leave it in 2 decimal places. That is 2.50. So the computed z or the test statistic is 2.50. Okay. So after getting a test statistic, then you arrive at a decision by saying that since 2.50, that is a test statistic, is greater than 1.65, the decision is to reject the null hypothesis. If you look at the decision, we said if the test statistic is greater than 1.65, we should reject the null hypothesis. So that is what you are doing here. Since 2.50, which is the computed value of z or the test statistic, is greater than 1.65, then the decision is to reject the null hypothesis. So after making decision, then we conclude. Now before we conclude, check the claim. The claim was a alternate hypothesis, isn't it? Remember in the previous video, where I talk about the introductory part of hypothesis test, I show you how to conclude that if the alternate hypothesis is the claim, okay, and you reject the null hypothesis, you should conclude that there is enough evidence to support the claim, isn't it? Alpha was given as 0.05, so we conclude that hence at 5% level of significance, there is enough evidence to support the claim. Okay. 5% is the same as saying 0.05. So you can also say at alpha equals 0.05, comma, there is enough evidence to support the claim. In fact, this particular question has even made your conclusion easy. Look at what the question says. The question says, is there enough evidence to support the claim? at alpha equals 0.05. So you just use the statement given in the question that at alpha equals 0.05, there is enough evidence to support the claim. So that is all for question 1. So let's look at question 2. Question 2 says, one of your distributors reports an average of 150 sales per day. You suspect that this average is not accurate. So you randomly select 35 days and determine the number of sales each day. The sample mean is 143 daily sales with a standard deviation of 15 sales. At alpha equals 0.01, is there enough evidence to doubt the distributor's reported average? So to solve this also, you write step 1, state the null and alternate hypothesis. Then you come down and state it. So you write H sub 0, then you bring your column. Then you come down and write H sub 1 and also bring your column. After writing this, then you go back to the question and check properly. The distributor reports an average sales of 150 sales per day. Now, when you look at this statement, if you put this statement in another sentence, it will say that the average sales per day is 150. So because of that word is, it is a statement of equality. And remember, a statement of equality goes for what? The H naught. So we are going to have mu equals 150. Average means mean. Okay. So mu equals 150. Then we just take the opposite of this. What's the opposite of equal to? That is not equal to. So mu is not equal to 150. Okay. Now, which of them is a claim? The claim is the what? The H naught, which says mu equals 150. Okay. Then you write step 2. Select a level of significance. So the question has given us a level of significance of 0.01. So you just write it alpha equals 0.01. Then after writing this, they write step 3. Identify the test statistic. So which test statistic are we using for this? So you check the question again. So you randomly select 35 days. How many days did you select? 35 days, which is more than 29. So since the sample size is a large sample, then it satisfies the condition of large sample. So we use the Z distribution. Okay. Even though the standard deviation is not a population standard deviation, but since the sample size is more than 29, that is, it satisfies the condition for large sample, you still use the Z distribution. So you say that the test statistic is a Z distribution. Then you write step 4, formulate the decision rule. Okay, so to formulate the decision rule, first we sketch a curve. Okay, now after sketching the curve, you check if it is a one-tailed test or a two-tailed test. So you come back to the set of hypotheses and check where the alternate is. Now when you check where the alternate is, you have a not equal to sign over there. Whenever you have a not equal to sign, it is a two-tailed test. So since this is a two-tailed test, just draw your line here and then do that for this side also and shade the two tails. So we shade this part and then we shade this part also. Now after shading them, then we take the level of significance and divide it into 2. So 0.01 divided by 2 should give us 0.005. Please use your calculator. Okay. When you get that 0.005, you give one to what? This side and then give the other one to this part also. So we have 0.005 for this shaded region and then we have 0.005 for this shaded part also. Remember, the shaded parts are known as the region of rejection and then the unshaded part is the region of acceptance. Okay. Then we will find a critical value of Z. Okay. So we need to find the Z score that will be here and then the Z score that will be here. Okay. So to do that, depending on the table you are using, if you are using a full table, you say 1 minus alpha over 2. Okay. If you are using a half table, you say 0.5 minus alpha over 2. But we already know alpha over 2 to be 0.005. Okay. So you say 1 minus 0.005. 1 minus 0.005 will give us 0.9950. Okay. And then those of you using the half table, we take 0.5 minus 0.005, and that will give us 0.4950. Okay. So we go to the z table. So let's check the full one first. 0.9950. So we look out for 0.9. So 0.9950 will be between 0.9949 and 0.9951. So we take the z-score of 0.9949, and then we also take the z-score of 0.9951 and find their average. So the z-score of 9949 is 2.57, and then for this is 2.58. So 2.57 plus 2.58 all divided by 2 should give you 2.575. Okay, in 3 decimal places. But in 2 decimal places, it will be 2.58. Okay. Let's use the half table and see. 0.5 minus 0.005 will give us 0.4950. So we are looking out for 4950. So here you can see that 0.4950 will be between 4949 and 4951. Okay. So when we check, you see that we get same answer, 2.57 and 2.58. So when you find the average, which is 2.575, okay, so we come back to the curve and then we write positive 2.575 for this part, and then we write negative 2.575 for this part. Okay, since it is two-tailed, okay, you can approximate it to 2.58. Okay, so positive 2.58 and negative 2.58. So now we formulate the decision rule. So the decision rule will be that if z is greater than 2.575, okay, we reject the null hypothesis. Okay, but if z is less than 2.575, we do not reject the null hypothesis. Okay, so like you take the positive, okay, you ignore the negative and use the positive for your interpretation. Okay, so in positive terms, if positive test statistic is greater than positive critical value, we reject the null hypothesis. But if positive test statistic is less than positive critical value, we do not reject the H0. So this is a decision rule you need to state. So step 5, take a sample and arrive at a decision. So we just write the formula for z. Since we are using z is equal to s bar minus mu divided by standard deviation over root n. Now, our s bar will be 143. The sample mean is 143. And our mu will be the population mean. It's even in the hypothesis, which is 150. Okay. And then we have a sample standard deviation of 15. But in the formula, you have population standard, so you have to replace it with s. Okay. And then the sample size is 35. Took a sample of 35 days. So we substitute that in the formula. So we're going to have 143 minus 150 all divided by standard deviation, which is 15 over root 35. So when you put this on your calculator, you get negative 2.76. Okay. Now, since we've gotten a negative answer, to make a decision, you just ignore the negative sign so that you won't get confused and then make your decision properly. Okay. So we say since 2.76 is greater than 2.575, the decision is to reject the null hypothesis. Okay. Since it is greater, then the decision is to reject the null hypothesis. Okay. So to conclude, first we're going to look at which of them is a claim. Here, H0 is a claim. Okay. Since H0 is a claim, you must conclude that at 1% level of significance, or you can say at alpha equals 0.01, there is enough evidence to reject the claim because the claim is H0 and then we've rejected it. So there is enough evidence to reject it. Now, in case you are in examination room and then you forget the decision rule, let me help you on another way of making decision. Okay. Now, this is what you do. Even if you are not able to state the decision rule as I've stated here, okay, what you do is that you come to the computed value of z, the test statistic. What was it? It was negative 2.76. Then you ask yourself, in case I want to write this negative 2.76 on this z-axis, where will it be? Negative 2.76 would have been somewhere here, in case you are writing it, isn't it? Let me say negative 2.1 would have been somewhere here, isn't it? And then positive 2.76 would have been somewhere here, isn't it? So since negative 2.76 would have been somewhere here, where does it lie? It's at the region of rejection. I told you that the shaded part is a rejection region. So it is clear that this is at the region of rejection. So this is one thing that can help you to come with your final decision. So you just check negative 2.76. In case you want to plot it on the z-axis, it would have been somewhere here, which is at the region of rejection. So because it is at the region of rejection, you are going to reject the null hypothesis. So you conclude that there is what? Enough evidence to reject the claim. But the question asks that, is there enough evidence to doubt the distributor's reported average? So you can go further to say, so there is enough evidence to doubt the distributor's reported average because you rejected the distributor's claim. So that is why we are saying there is enough evidence to doubt the distributor's reported average. So let's look at question 3. Question 3 says, a light bulb manufacturer guarantees that the mean lifetime of a certain type of light bulb is at least 750 hours. A random sample of 36 light bulbs has a mean life of 745 hours with a standard deviation of 60 hours. At alpha equals 0.02, do you have enough evidence to reject the manufacturer's claim? So to solve this, first we write step 1, state the null and the alternate hypothesis. So to state the null and the alternate hypothesis, just write h sub 0, then you bring your column. Then you come here, h sub 1. Okay, you can write it h sub a also. Then you bring your column. Okay. Then you go back to the statement. A light bulb manufacturer guarantees that the mean life of certain type of light bulb is at least means what? Greater than or equal to. And greater than or equal to sign is a statement of equality. So since it is a statement of equality, remember I told you a statement of equality should go for H naught. Okay. So if that is the case, then we are going to write that mu is greater than or equal to 750 hours. So you just write the opposite for H sub A. So mu will be less than 750. So that's all. Then which of them is a claim? It is H naught. H naught is a claim, okay. Then you write step 2, select a level of significance. So the question has given us significance of 0.02. So we write alpha equals 0.02. Okay. Then after doing that, then we write step 3, identify the test statistic. So how do we identify the test statistic? We go and check the standard deviation or the sample size. We go and check if the standard deviation is a population standard deviation, or we check if the sample size is greater than 29. So let's check the standard deviation first. They say a random sample of 36 light bulbs has a mean life of 745 and a standard deviation of 60. So it means that this mean is referring to the sample, so it is a sample mean. But because of the word width, it means that they are both referring to one thing. Okay, the mean and the standard deviation are both referring to the same subject. So the standard deviation is also a sample standard deviation, not a population standard deviation. So since this standard deviation is a sample standard deviation, it's not enough to show that we are going to use Z. Now let's check. The sample size is more than 29. That is, it satisfies the condition that n should be greater than or equal to 30. Okay, so since this satisfies the condition for a large sample, then you say that the test statistic is a Z distribution. You can even write the reason that this is because the sample size is greater than 29. Okay, or you can say this is because the sample size is greater than or equal to 30. Then you write step 4, formulate a decision rule. So to formulate a decision rule, we sketch a curve. Now, check. This is a left tail test. Okay, it is a less than sign, so it is a left tail test. So we shade the left tail. Okay, so after shading the left tail, since it is a one tail test, we give all the alpha 0.02 to the left. So we are going to have 0.02 here. Okay, then we'll proceed to the z table. For those of you using a full z table, we say 1 minus alpha because it's one tail test. Okay, so 1 minus 0.02 should give us 0.9800. Okay, and those of you using a half table, we say 0.5 minus 0.02, and that will give us 0.4800. Okay, so we go to the table. So when we come to the table, we look out for 0.9800. Okay, let's look for it. Now we have 0.9803 here, and then we have 0.9798 here. I think 0.9798 is even more closer to 0.9800 than 0.9803. Now you can decide to take the z-score of the two of them and find the average. Or you can also decide to just take the z-score of the 0.9798 since it is more closer. So the z-score of 0.9798 is 2.05. Okay, so it is 2.05. In case you are using a half table, 0.5 minus 0.02 give you 0.4800. So we look out for it. This is 0.4803 and this is 0.4798. This is more closer. Okay, so we take the z-score, that is 2.05. You see that we get the same answer, 2.05. So we go back to the curve. Now, it is a left tail test. Okay, even though we got 2.05, make sure you add negative to it because it's at the left side. Okay, so negative 2.05. So that's it. So this is a critical value. So we write the decision rule. So to write the decision rule, ignore the negatives. That's why I brought this sign. It is called absolute value of something. So absolute value of a negative value is positive. So I'm just trying to tell you that if positive z is greater than positive 2.05, you reject the null hypothesis. But if positive z is less than positive 2.05, you do not reject the null hypothesis. Okay, so step 5, take a sample and arrive at a decision. So z is equal to x bar minus mu divided by standard deviation over root n. The mu is what is in the claim, which is 750. Okay, and the sample mean is 745. They say a random sample has a mean of 745. Okay, and a standard deviation of 60. So we substitute them into the formula, and the sample size is 36. So we're going to have 745 minus 750 divided by 60 over root 36. Now root 36 will give you 6. 60 divided by 6 is what? Is 10. And then at the numerator, 745 minus 750 is negative 5. So negative 5 divided by 10 is negative 1 over 2. And negative 1 over 2 in decimal is negative 0.50. Okay. So the calculated z or the computed z or the test statistic is negative 0.50. When you want to make decision, you ignore the negative so that you won't make a mistake. Okay. Say that since 0.50 is less than the critical value, which is 2.33, the decision is to fail to reject the null hypothesis. This is not 2.3, it's 2.05. 2.05. Okay. So since it is less, it is not more. If it is more, that is when we reject. But since it is less, the decision is to fail to reject the null hypothesis, or we do not reject the null hypothesis. Okay. So how do we conclude? When you look at this, you realize that the claim is the null hypothesis. And remember, whenever the null hypothesis is a claim, and then you do not reject the null hypothesis, you conclude that there is no enough evidence to reject the claim. Okay. So we can answer in accordance with the question by saying that hence at 2% level of significance, or you can say at alpha equals 0.02, there is not enough evidence to reject the manufacturer's claim. So let's look at question 4. Question 4 says, average undergraduate cost for tuition fee, room and board for all institutions last year was. $19,410. A random sample of cost this year for 40 institutions of higher learning indicated that the sample mean was 22,098 and the sample standard deviation was 6,050. At the alpha equals 0.01, is there sufficient evidence to conclude that the cost of attendance has increased? Even though when you read the question, it says last year was, what is the present of was? It is. Here you'll be thinking it is a statement of what? Equality. No problem. But be very careful. When you get to the last part, which says you want to test whether it has increased, you should be very careful about that. You can also say you want to test whether it has decreased. You should also be careful about that. So let's see how to solve this. Now, first, we say step 1, state the null and alternate hypothesis. Okay. So we write H naught, then we bring our column. Then we also write H sub 1 or H sub A and then bring column. Now, the statement says we want to check whether it has increased. Increase means greater than. So it's inequality. So we assign this to the alternate hypothesis. So we say mu is greater than 19,410, which was stated here. Okay. Now, at the null hypothesis, you can write the opposite of this, which is less than or equal to. So you have mu less than or equal to 19,410. And you can also write it mu equals 19,410. Okay. It's not wrong. It's correct also. Because of this word was. If you change it to present, it means is, which is equality. So you give equality to H naught. And then increase means greater than. So you give it to H sub A or H sub 1. Okay. But if you use less than or equal to, as I taught you earlier to, it's not wrong, it's correct. What matters the most is that your alternate path should be very, very correct. Okay. But then now you can decide to use the opposite of the alternate or use equal to sign. It doesn't matter. Okay. Then we go to step 2. Step 2, we select a level of significance. So the level of significance given was 0.01. So we say alpha equals 0.01. 0.01. Then step 3, we identify the test statistic. So to identify the test statistic, we look at the question. When you look at the question, you see that the sample size is 40, which is more than 29. That is, it satisfies the condition that n should be greater than or equal to 30. So for that matter, we are using a z distribution. So we say the test statistic is a z distribution. Okay. Then then we write step 4, formulate the decision rule. So to formulate the decision rule, you sketch a curve. After sketching the curve, you tell if it's a one-tailed test or a two-tailed test. So when you look at this one, you look at the alternate part, okay? You have a greater than sign. So it is a one-tailed test, okay? But to be specific, it is a right-tailed test. So we are going to shade the right tail. Then we give the 0.01 to the right tail. So we have 0.01, okay? Then we find a critical value of z. To get a critical value of z, we are going to use a z table. So those of you using a full table, take 1 minus 0.01, you get 0.9900. And those of you using a half table, take 0.5 minus 0.01, you get 0.4900. So let's check the table. So let's check 0.9900. So when we check, 0.9900 will be between 0.9898 and 0.9901. But it looks like 0.9901 is more closer to it than 0.9898. So we can just take the z-score of 0.9901. That will be 2.33. And then if you are using the half table, 0.5 minus 0.01 will give you 0.4900. So let's look for 0.4900. So we have 0.4898 and 0.4901. 0.4901 is more closer to 0.4900 than 0.4898. So when we take the z-score, so we see that we get same answer, 2.33. So the critical value of z is 2.33. So since it is at the right, so we write the 2.33 here. Then we formulate the decision rule that if the computed z, that is a test statistic, happens to be greater than a critical value, the one here, we should reject the null hypothesis. But if it is less, then we do not reject the null hypothesis. Okay. So after formulating a decision rule, then we write step 5. Take a sample and arrive at a decision. So to do that, we are using the z. So we say z is equal to s bar minus mu divided by sample standard deviation over root n. So our mu is here, and then x bar is 22,098. It said a random sample of course this year for 40 institutions of higher learning indicated that the sample mean was 22,098. Sample standard deviation is 6,050. So we substitute that in the formula. So we're going to have 22,098 minus the population mean, which is 19,410, all divided by the sample standard deviation is 6,050 divided by square root of the sample size, which is 40. When you put this on your calculator, you get positive 2.81. So you write that since positive 2.81 is greater than 2.33, the decision is to reject the null hypothesis. Okay. The computed z, which is this, happens to be greater than 2.33. So because of that, we reject the null hypothesis. So we write it here. Since 2.81 is greater than 2.33, the decision is to reject the null hypothesis. Okay. Another way of making decision is by checking 2.81. If I should plot it on this z-axis, where will it be? It is more than 2.33, so it will be plotted somewhere here. 2.81, isn't it? So you realize that it lies at the region of rejection. So that tells you that you are going to reject the null hypothesis. So the decision is to reject the null hypothesis. The question is that is there sufficient evidence to conclude that the cost of attendance has increased? Since we've rejected the null hypothesis, it means we are supporting HA. So you have to conclude that hence, at 1% level of significance, there is sufficient evidence to conclude that the cost of attendance has increased because you've rejected this. And this is saying that it has increased and you've ended up accepting this. It means you are supporting the one that says it has increased. Okay, so I'll end it here for now. You can watch the video over again. And then in the next topic, we are going to look at one sample hypothesis test for mean when the population is approximately normal. At the same time, the sample size is less than 30, and at the same time, the population standard deviation is not known. We look at that and how to solve question on it. Okay, thank you.